Zoe adjusted her VR headset. The virtual lab shimmered to life. Bots whizzed past. Sparks flew. "Develop your STEM skill sets," a voice echoed. Today, Zoe, 12, was ready for a challenge. This wasn't just a game. It was the annual Robotics Rumble competition. Her team, the Circuit Breakers, needed to program a rescue bot. "All right, team," Leo, 13, shouted. He was all about the mechanics. "Our bot, Sparky, needs to navigate the Lost City maze, find the data core, and bring it back." Sparky, a compact, wheeled robot, sat innocently on the workbench. It looked simple. Zoe knew better. Maya, 11, grinned. She was the coding prodigy. "And we have a new obstacle this year. Glitch blocks. They mess with Sparky's sensors." This was going to be tough. Their challenge? Develop their STEM skill sets to win. This story, for 10 to 13-year-olds, dives into STREM learning, problem-solving, and a thrilling robotics adventure. First, they tackled navigation. "Sparky needs to see the walls," Zoe explained. "Infrared sensors, Leo." Leo nodded, pulling out a tiny circuit board. He soldered the sensors in place. Delicate work. Precision was key. One wrong move, and Sparky would be blind. "Now, the code," Maya said. Her fingers flew across the keyboard. "We program Sparky to move forward. If an infrared sensor detects a wall, it turns." This was basic robotics, but the maze was complex. Dead ends everywhere. Simple turns wouldn't cut it. "We need a right-hand rule algorithm," Zoe suggested. "Always keep the right hand on the wall. Eventually, it'll find an exit." Maya's eyes lit up. This was logical thinking, a path-finding algorithm. She started typing, translating the strategy into lines of code. "If sensor underscore right underscore blocked, colon, turn underscore left, else colon, move underscore forward." The first test run. Sparky rolled into a miniature maze. It hit a wall. Turned left. Great. Then a dead end. Sparky spun in circles. "Uh-oh," Leo mumbled. "It's stuck." "It doesn't remember where it's been," Zoe realized. "We need to add memory, a visited map." This was where advanced coding came in. Maya designed a grid system. Each square Sparky visited was marked. If it hit a dead end and all surrounding squares were visited, it would backtrack. This involved loops and conditional statements, crucial coding concepts. Maya used a while loop, while not data underscore core underscore found, colon. Inside, if statements checked sensor readings, else, if managed visited squares, and a break command exited the loop when the core was found. This taught them about structured programming, how smart devices use logic to operate. Next, the glitch blocks. These blocks emitted a signal that scrambled Sparky's optical sensors. "We can't see the data core when we're near them," Maya fretted. "How do we find it?" This was a real-world connection. How do robots operating in hazardous environments cope with compromised sensors? "What else can Sparky feel?" Zoe pondered. "Sound? Touch?" Leo tinkered. "We have a small ultrasonic sensor. It measures distance using sound waves. Like bats." This was engineering principles in action, using different types of sensors to overcome limitations. "Perfect!" Maya exclaimed. "When the optical sensors are jammed by glitch blocks, we switch to ultrasonic. We can program Sparky to use sound to ping for the data core." The data core in the maze would have a distinct ultrasonic signature. This was a sophisticated piece of coding. It required creating a function to switch between sensor modes. Def switch underscore sensor underscore mode, open parenthesis, mode, close parenthesis, colon. They wrote code for Sparky to detect the glitch block signal. When detected, optical sensors would shut down. Ultrasonic mode would activate. Sparky would emit ultrasonic pulses. If the wave bounced back with a specific pattern, it meant the data core was near. But what if the glitch block signal also affects the ultrasonic sensor? Leo asked, ever the pragmatic one. We need a backup for the backup. Zoe smiled. Good point. What if we can't see or hear? We need to feel it. This was pushing their engineering creativity. Leo had an idea. We could add a tiny magnet. The data core has a magnetic field. When Sparky gets close enough, the magnet detects it. He rummaged through his toolkit. A tiny neodymium magnet, a magnetic field sensor. More soldering. More precise circuitry. This highlighted how multi-layered real-world robotics can be. Think of surgical robots that use multiple sensing modalities for precision. Now, the coding for the magnetic sensor. Maya integrated it as a final fallback. ELIF, magnetic underscore field underscore detected, colon, retrieve underscore data underscore core, open parenthesis, close parenthesis. This nested if-elif-else structure became increasingly complex, mirroring the intricate decision-making processes in advanced AI. The day of the Rumble arrived. The arena hummed with excitement. Other teams' robots zipped, whirred, and clanked. Some were